The question is, let z be equal to 2 minus 2i, sorry, z1 is equal to 2 minus 2i, and z2 is equal to minus 1 plus 4i. Express the following in the form a plus bi. And there's 3 to do. Of course, the point is that every complex number can be written in this way because that's the definition of a complex number. So we arrange our definitions of multiplication and conjugate and division so that it's possible to rewrite any number in the form a plus bi. So let's go. A. Z1 bar Z2 minus 3Z2 squared bar. Alright, well, I'll just do each bit separately and see what happens. So let's see. Z1 was equal to 2 minus 2i. So the conjugate, Z1 conjugate, Z1 bar. So when you do conjugates, it's the same number, but I changed the plus or minus of the imaginary part. So 2 plus 2i. And so Z1 bar times Z2 would be 2 plus 2i times Z2, which was minus 1 plus 4i. And so that's equal to, well, let's see. 2 times minus 1 is minus 2. 2 times 4i is 8i. 2i times minus 1 is minus 2i. And 2i times 4i would be 8i squared. Okay, so let's just think about this. We've got minus 2. 8i minus 2i would be 6i. And 8i squared, well, I squared is minus 1, so that would be minus 8. So that would be minus 10 plus 6i. Alright, so what have we got next? We need to do minus 3z squared bar. So, okay, z2 squared would be equal to minus 1 plus 4i squared. So let's see, minus 1 squared plus 2 times minus 1 times 4i plus 4i squared. So minus 1 squared would be 1. 2 times minus 1 times 4 is minus 8i. 4i squared, so 4 squared would be 16 and I squared would be minus 1. So minus 15 minus 8i. Okay, so I do 3 times that. So 3 times z2 squared would be minus 45 minus 24i, because that would be what I get when I multiply the previous one by 3. And 3 times z2 squared bar would be the same, but changing the sign of my imaginary part, so plus 24i. So finally, z1 bar z2 minus 3, minus 3z2 squared bar is, so z1 bar z2 was minus 10 plus 6i, and 3z2 squared bar was minus 45 plus 24i. So 10 minus minus 45 would be 10 plus 45. Sorry, minus 10 minus minus 45 would be minus 10 plus 45, which would be 35. And 6i minus 24i would be minus 18i. So there's my answer. Let me do the next one. B. Alright, what we want I z1 bar plus 3 minus I z2 squared. Okay, so let's see. I times z1 was I times 2 minus 2i, which was 2i minus 2i squared, which was 2i times 2 times minus 1, which was 2 plus 2i. So I z1 conjugate would be the conjugate of this, which would be 2 minus 2i. Okay. 3 minus I times z2 would be 3 minus I times minus 1 plus 4i. Okay, so let's see. 3 times minus 1 is minus 3. 3 times 4i would be 12i. Minus I times minus 1 would be plus I. And minus I times 4i would be minus 4i squared. So let's see, we get 13i, and minus 3 minus 4 times I squared, but I squared is minus 1, so that would be minus 3 plus 4, which would be 1. Okay, so now I need to add them together. So I z bar plus 3 minus I times z2 is equal to 2 minus 2i, that's I z bar, plus 1 plus 13i, which is 3 plus 11i. So 2 plus 1 is 3, minus 2 plus 13 is 11. Excellent. And so I z1 bar plus 3 minus I z2 squared would be 3 plus 11i squared, which would be 3 squared, which is 9, plus 2 times 3 times 11i plus 11i squared. So let's see, we have 9 plus 66i. 11 squared is 121. I squared is minus 1. So 9 minus 121 would be minus 112 plus 66i. Alright, next one. Okay, so this time we want C z1 over z2. Well, that would be equal to 2 minus 2i over minus 1 plus 4i. And I want to write it in form a plus bi, so if that bottom was a real number, I could just divide the two parts separately because all the rules of algebra still work. So if I could achieve the bottom being a real number, that'd be great. Now, if I multiplied top and bottom of my fraction by the right thing, I could probably convert the bottom into a real number. And you know what? It's the conjugate that does that. The conjugate is the unique number that adds to z2 and multiplies to z2 to give a real number. So I reckon we should multiply by minus 1 minus 4i, minus 1 minus 4i. Now I have to multiply by minus 1 minus 4i over minus 1 minus 4i because that's multiplying by 1, and so I haven't changed my answer. I have to multiply the top and the bottom by the same thing. So let's see. 2 times minus 1 is minus 2. 2 times minus 4i would be minus 8i. Minus 2i times minus 1 would be plus 2i, and minus 2i times minus 4i would be plus 8i squared over, well, that's the difference of two squareds. I have minus 1 plus 4i times minus 1 minus 4i, so that will give me minus 1 squared minus 4i squared. Pardon me. So that would be minus 2 minus 6i, and 8i squared is minus 8, over 1 minus, now 4 squared is 16, and I squared is minus 1. So that would be minus 10 minus 6i over 1 minus minus 16, so 17. So that would be minus 10 over 17 minus 6 over 17i. And I've finished the question.